Today, we're going to pull back the curtain on one of the most powerful tools in all of system design, caching. This is the secret weapon for making things fast. And I'm not talking about a minor tweak here. Caching is a core design decision that literally makes the modern internet feel instant.
I mean, you've felt this, right? You tap a button on one app and boom, it's there. You do the same thing on another and you're just staring at a loading spinner, waiting. Well, that feeling of speed, the secret ingredient behind it is almost always a really smart caching strategy. So here's our game plan. We'll kick things off with why speed is so critical in the first place. Then we'll look at where caches actually live in a system and the clever strategies that dictate how data moves around. We'll also get into the all-important rules for keeping a cache fresh, and then we'll jump into some real-world examples and finish up by talking about the critical trade-offs you always have to make.
All right, let's dive into part one, the need for speed. Before we can even get into the how of caching, we really need to understand the why. Why is raw speed so essential, and why does caching matter so much?
You know, at its heart, caching is a beautifully simple idea. Just think of your database as a huge supermarket. If you need ingredients, you can always go there, but it takes time to drive over, find what you need, and come back. A cache, well, that's like your kitchen pantry. It's way smaller, but it holds the stuff you use all the time, so you can just grab it instantly. That's all caching is. We're just storing data in a much faster place, usually in memory, to avoid that slow trip to the database every single time.
And the benefits? They are massive. They touch every single part of the system. For you, the user, it means way less waiting and a much better experience. But for the system itself, it's like a protective shield. It drastically cuts down the load on the database and reduces all that network chatter. And what does that mean? It means you can handle way more traffic with less hardware, which saves a ton of money. Honestly, most of the big websites and apps you use today just couldn't survive without it.
Okay, so this brings us to a really key idea. Caching isn't just one thing you plug into your system. It's actually a strategy that you can apply at many different layers. And where you decide to put your cache has a huge impact on performance.
The golden rule is pretty simple. The closer the cache is to you, the faster it is. So the absolute fastest is client-side caching, happening right there in your web browser or on your phone. The next layer out is a content delivery network, a CDN, which stores things like images on servers all around the world close to you. Go a little deeper and you hit the application-level caches using tools like Redis. And then, believe it or not, even the database itself has its own internal caches to speed up its own work. Every single layer is there to shave off precious milliseconds.
So we know where to put a cache, but how do we actually get the data in and out? Well, that's where caching strategies come in. Think of these as the rules of the road that control how data flows between your app, your cache, and your database.
When it comes to reading data, it's really a question of who's in charge. The most common pattern by far is called cache aside. Here, your application takes control. It checks the cache first. If the data isn't there, that's called a cache miss, the app goes and gets it from the database itself. And then it puts that data into the cache for the next time. The other approach is read through, which actually makes the application's job simpler. The app just talks to the cache, and the cache itself is smart enough to go fetch any missing data from the database on its own.
Now, for writing data, you face this classic trade-off. Do you want safety or do you want speed? Write-through is the safe option. It writes to both the cache and the database at the same time, which guarantees they're always in sync. But if you want maximum speed, you can use write-back. With this strategy, you write only to the super-fast cache first, and then tell it to update the database later, in the background. The performance is incredible, but, and this is a big but, it comes with a risk. If that cache fails before the data gets saved to the database, that write is gone forever. Okay, so every cache has one fundamental problem. It can't hold everything. Space is limited. So, what happens when it's totally full and you need to add something new? You've got to have a rule to decide what gets kicked out, and that crucial rule is called an eviction policy.
Let's quickly break down the most common ones. LRU, or least recently used, is really the workhorse of caching. It just assumes that if you haven't touched something in a while, you probably don't need it anymore. LFU, or least frequently used, is a bit smarter. It evicts the item that's been accessed the fewest number of times. Then you have FIFO, first in, first out. It's super simple. The oldest thing in the cache is the first to go. And finally, there's TTL, or time to live. This one isn't about the cache being full, it's about making sure data doesn't get old and stale. It just automatically deletes data after a set period of time. All right, that's enough theory. Let's get practical. Let's look at the tool everyone in the industry uses and some of the incredible ways caching is powering the apps we use every single day. When engineers talk about application-level caching, 9 times out of 10, they're talking about Redis. It's this open-source, in-memory data store that is just purpose-built for one thing: unbelievable speed. I mean, we're talking sub-millisecond response times. It's just perfect for high-performance cache. So where do you see this in action? Oh, it's everywhere. When you log into a website, your session info is probably in a cache. Scrolling through your social media feed, that's a cached list of posts. That product catalog on an e-commerce site, the results from an API call, a leaderboard in a video game, even the thing that stops you from spamming a login button too many times. All of it powered by caching. So, caching sounds like magic, right? Just add it and everything gets faster. Well, not quite. While it's amazing at solving the problem of speed, it brings a whole new set of complexities and challenges to the table. It is a powerful tool for sure, but it is definitely not a magic bullet. See, the fundamental problem is this. The moment you add a cache, you've created a second source of truth for your data. And keeping that in sync with your main database is really, really hard. You have to worry about things like cache invalidation, knowing exactly when to throw old data away. You have to try and avoid a cache stampede, which is this nightmare scenario where a popular item expires and suddenly thousands of requests all slam your database at the exact same time. It all comes down to this. You've solved your speed problem, but you've just created a data consistency problem. And this quote just sums it all up perfectly. The hardest part of all of this isn't setting up the cache. It's figuring out that perfect moment to declare that your cached data is no longer good. If you get it wrong, you either show your users old, stale information, or you hit the database so often that you defeat the whole purpose of having a cache in the first place. But even with all those challenges, let's be absolutely clear on the final takeaway here. For any system that's operating at a serious scale, caching is not a nice-to-have. It's not some optional optimization you do at the end. It is a foundational, absolutely non-negotiable part of the architecture. So I'm going to leave you with this question. The next time you're using your favorite app and it just feels blazing fast, take a second and think about all those invisible caching layers working hard behind the scenes. Where in the apps you use every day do you think a well-placed cache is making all the difference?